For this problem, we're going to look at this parametric curve, x is equal to cosine t, y is equal to 2 sine 2t, and determine where there is a horizontal tangent line and where there is a vertical tangent line. Okay, now for this problem, we can just eyeball it. We can see that there's going to be vertical tangent lines here. So almost certainly at -1, 0 and at +1, 0, there are going to be vertical tangent lines. It also looks like there are going to be 4 spots where there are horizontal tangent lines, but it's not quite so obvious how to read those points off. And so we'll take a look at being able to identify those points as well. Although it does look like the y coordinates are -1 at these 2 points, and the y coordinates are +1 at these 2 points. Okay, so to do this problem, let's figure out uh, equation or the slope of the tangent line. dy dx is given by dy dt over dx dt, as long as the denominator is not 0. More on that in a second. And in this case, dy dt is going to be equal to 2 times the cosine of 2t. And dx dt is going to be negative sine t. Okay, so let's figure out where we have the denominators equal to 0. So vertical tangent line. The vertical tangent line occurs when sine of t is equal to 0, and that occurs when t is any multiple of pi. Okay, so let's figure this out. So if n is equal to 0, we would get that t is equal to 0. And that would mean that x is equal to the cosine of 0, which is 1, and that y is equal to sine of 2 times 0, which is 0. Okay, that's one place it happens. The other place that it's going to happen is when n is equal to 1. If n is equal to 1, then I have 1 times pi, so the time will be pi. And so that means x is equal to cosine of pi, which is -1. And y will be equal to the sine of 2 times pi, which is 0. Okay, so there we have it. So our vertical tangent lines will occur at the points 1, 0 and -1, 0. Okay, so that's straightforward. Now let's now figure out where we're going to have the horizontal tangent lines. The horizontal tangent lines will occur that occurs when the numerator is equal to 0. So the vertical tangent line occurs where we have a 0 in the denominator and that the fraction is undefined. Well, horizontal tangent line just means that the numerator is 0, so 0 over something is 0. So the horizontal tangent line occurs when we have that 2 times cosine of 2t is equal to 0. Okay, now the cosine, we can get rid of the 2. Cosine of 2t equals 0. And the cosine function is equal to 0 when we're at a half multiple of pi, pi over 2 plus pi n. So that means 2t is going to be equal to 2 pi. Let's write like this. Pi over 2 times 2n plus 1. Okay, so here the 2's would cancel, and I get this. And therefore, t would be equal to pi over 4 times 2n plus 1. Okay, and let me recopy over here so I have it on screen. My function was x is equal to cosine of t, and y was equal to sine of 2t. So let's again start on the values of n and see what happens. So if n is equal to 0, that means t would be equal to 1 times pi over 4. And so that would mean that x is equal to the cosine of pi over 4, which is square root of 2 over 2. And y would be equal to the sine of 2 times that, of 2 times pi over 4. So that's sine of pi over 2, which is equal to 1. And so there's our first point. Square root of 2 over 2, 1. Okay, now let's plug in different values of n and figure out the other 3 points. If n is equal to 1, if n is equal to 1, I would have 2 plus 1, 3 pi times pi over 4. And so x would be equal to the cosine of 3 pi over 4, which is negative square root of 2 over 2. And y would be equal to the sine of twice that, so 6 pi over 4, or 3 pi over 2. And that is equal to negative 1. And so this would be equal to negative square root of 2 over 2, negative 1. Next, if n is equal to 2, that means t would be equal to 4 plus 1, so 5 pi over 4. And so x would be equal to the cosine of 5 pi over 4, which is negative square root of 2 over 2. And y would be equal to the sine of 5 pi over 2, twice this. And the sine of 5 pi over 2 is plus 1. So that would be negative square root of 2 over 2 plus 1. And finally, if n is equal to 3, then I would have t is equal to 7 pi over 4. Because if I plug in 3, I get 6 plus 1, 7 times pi over 4. And so x is equal to the cosine of 7 pi over 4. That's in the fourth quadrant, so cosine is positive, square root of 2 over 2. And then y would be equal to the sine of 7 pi over 2. And that will be equal to negative 1. And so that is my fourth point. Positive square root of 2 over 2, negative 1. And if I plugged in n equals 4, I would actually come right back up here again and cycle through those 4 examples again. If I were n equal 4, 5, 6, 7, I would just simply get these 4 values all over again. Okay, so in conclusion, coming back over here, I have vertical tangent lines at 1, 0, and negative 1, 0. And I have horizontal tangent lines at 4 points, at plus or minus square root of 2 over 2 and plus or minus 1. And so these 4 points where I have horizontal tangent lines, the x coordinate is either plus square root of 2 or negative square root of 2, and the y coordinate is either plus 1 or negative 1. And so that's where the horizontal tangent lines occur. And the vertical tangent lines are going to be the ones over here at negative 1, 0 and at plus 1, 0.